No calculator, okay. So what would the area of R be?
The area of R would be the top curve minus the bottom curve, which...
Yeah. Okay.
So the top curve is 19 minus x squared, and the bottom curve is x squared plus 1, so it would be the integral from 0 to 3 of 19 minus x squared minus x squared plus 1.
Okay, simplify that.
We'll split it up into 2. Or we can just...
Yeah, just combine everything. So we got 18 minus 2x squared, right?
Right.
From 0 to 3. It's relatively simple. You know how to do that, right?
Yeah.
Okay. Notice that there is another way that this could be done. In other words, we're doing it with those kind of rectangles and integrating it with respect to x, but it could be done this way. Integrating it with respect to y.
Right.
And you would go from 1 to 19. And you would also have to change each of these functions. Actually, you would go from 1 to whatever that intersection point is there, 10, using one function. And
right.
You would go from here up to here, from 10 to 19, using the top function.
Okay.
And you would have to turn those functions into functions of y. In other words, if I start with y equals 19 minus x squared, I got to solve that for x in terms of y, and you get plus or minus the square root of 19 minus y. And this always introduces a few problems. But it could be done that way also.
Okay.
So let's scroll down what the next question is here. It's hard to imagine they're going to have very many. A solid is formed by revolving R about the x-axis. Find the volume of the solid. Okay.
So that would be pi times the integral.
Well, first of all, figure out what we're going to use. Can we use washers or discs?
We're going to have to use discs.
Think washers. Notice that when you revolve it, you're going to end up with an object. Let's see if I can come close to drawing it. It's going to have a hole in it. In other words, this part here goes like that. Top part goes like that. And you have this solid that has two mountains on it. And it's got a hole right there. So when there's a hole, you got to use washers.
Right.
Okay, so if we're using washers, that affects the formula. What is it goes inside?
Well, it's big R minus little r.
Is it big R minus little r squared, or is it big R squared minus little r squared?
Big R squared minus little r squared.
Okay. And so in our case, big R is what?
Big R would be the top curve, so 19 minus x squared. And then little r would be,
got to square that, make sure.
19 minus x squared all squared. But little r would be, wouldn't it be 1 minus the function because there's...
What is the function? I'm not having it on my screen right now.
Oh, 1 minus x squared plus 1 because there's a little hole right there in the between the x-axis and the function.
Hold on, let me look at what the function is. X squared plus 1. So this is x squared plus 1. Wish they would do this. It would make it easier. So little r is that radius right there.
So would big R,
as you move to the right, that's little r. Remember, I'm rotating it over the x-axis. So by
right,
the time I have my new figure, the distance is 2r between those two things, which makes r that. Little r is that.
right.
So it should be the integral of pi big R squared, what is it again, 19?
19 minus x squared.
All squared. Minus little r squared. Whoops. Dx. And
So it's just a
different answer, obviously, because we're squaring everything.
Right. So it's just a function minus. So little r is just a function.
Yeah. I think the situation you were referring to is when you are rotating it about a line that is not the x-axis. Let's say we're rotating it about a line that the line x equal 1/2.
Okay.
Okay. In other words, if we're going to rotate it about this line right there.
Okay.
Now, little r is not x squared plus 1. It's x squared plus 1 minus 1/2.
Right.
So whenever you're rotating about the x or the y-axis, I don't think you have to worry about making those adjustments.
Okay.
There are some problems. Usually they involve cylindrical shells, which you don't have to know, right?
No, we do not need to know the shell.
Right. Yeah, it's puzzling that you don't, the shells, cylindrical shells are not on the test, but integrals of trig functions are.
Right.
Which is odd because cylindrical shells goes in this category. Solids of evolution. It's just much more complicated to think about. Cylindrical shells are much harder to picture.
Right.
Okay, so you can do that integral there?
Yes.
Okay. Solid has its base as region R, whose cross sections perpendicular to the x-axis are squares.
So since they're perpendicular to the x-axis, we're going to be integrating with respect to x.
Correct.
Correct?
Correct. Now, let me just make an attempt to draw what this would be. In other words, we're going to have a square. We're going to have a square like that. Right? And that's looking from the top. In other words, it's a three-dimensional view. And then down here, you get a square. God, I'm such a bad artist.
Sorry.
Basically like that. So
It's hard to draw.
each square's base is the distance between these two functions.
Okay.
Okay? So we're going to integrate what is the very first square you would start with on the left, and then we're going to add them all up as we go to the right. So what is that first square's area? Surface area. Remember, you get its volume by its surface area times dx.
Right.
That's equal to
So
dv. Yeah.
the surface area, well, that would be s squared.
Okay. So it's s squared. And what's the first s?
19 minus x squared minus the other function, x squared plus 1, and then all squared.
Yeah, that's this distance right there. So that first square is going to have a base of that. And then that distance has to be squared to give you the area. And that gives you the volume.
And then you don't need to
Need to integrate from 0 to 3.
right, you don't need to use pi in front when you're doing cross sections.
Correct. The only time you should have pi's, well, sometimes when you're doing cross sections, if they're like semicircles.
Right.
In other words, pi's, you need to have curvature.
Okay.
If everything is a geometric straight edged object like triangles, squares, then you're not going to have pi in your answer.
Okay.
Okay. All right. And let's see if there's any other questions on this. I don't think so. Okay. So we're done with this page?
Yeah.
I guess it's obvious that this point is 3. Probably safe to assume at least.
Yeah, since it's non-capital.
Probably, if your life depended on it, you'd want to do the math. How would you find out what that point really was? The intercept.
You set the equations equal to each other.
Yep. Okay. So that was that page. Let me move that out of the way so I'm not going to. I got to go through and start naming these and storing them somewhere. All right. So this is the velocity function.
Right.
So this is v of t.
So,
at what times in the interval does the particle change direction? Explain your answer. Ooh, okay. The more typical beginning problem on these is a particle's on the x-axis and it's moving back and forth on the x-axis. Okay.
right.
So a change in direction is a 180-degree change in direction. Well,
Okay.
I think they don't say that here. They just say any change in direction. And the particle is moving in 2 dimensions or not? Am I interpreting this wrong? A particle begins on the y-axis and travels along a straight line. By that, do they mean it travels along the y-axis?
No, I think they mean the straight line is the x-axis.
So it begins right here and it moves back and forth on the x-axis. It would be incorrect to interpret the particle doing following that line.
Okay.
Okay. Hold on a second. Let me start over here so I can bring up my writing. Yeah, I believe you're probably right. No, it starts right here at that point, 0, 4. So it's not on the x-axis. Maybe they do mean in 2 dimensions. Let's see if we can figure this out. I wish they would have labeled their axes. This clearly is t. It's always t. And if this is y, but what we're looking at here is its speed. In other words,
Right.
its speed starts out at 4 feet per second from that point, 0, 4.
Right.
And then its speed gets up in the first 2 seconds to 8 feet per second.
So, I think,
And then the speed stays the same.
well, I think I would just interpret this as, so since it's asking what times in the interval does a particle change direction, that would just be when the velocity, since this is the velocity graph, is changing sign.
I agree. That's the only way I can figure out how to do it, because it doesn't change direction there. Right? I mean, it starts at 4 feet per second, and then it's going 8 feet per second. It stays going 8 feet per second for a while, and then it comes all the way down to 0 feet per second. That's the point where it changes directions, because then its velocity is negative.
Right. So, yeah, that's what I think. So,
Yeah.
it would change direction.
Figure it out in 2 variables. That's probably calculus of 2 variables. But since we're calculus of 1 variable, I guess it meant, yeah, it travels along a straight line. See, it's hard not to look at this and think the particle might be doing something like this. That's not, this travels along a straight line means it's either doing that, or it's doing that, or it's doing that, but it's not changing from that straight line. The only thing it's doing is reversing. And that's what they're asking, I believe. Okay. So it's reversing at 6, 0. Where else?
And 12, 0.
Yeah, and I think that's the answer.
Yeah, and then you just explain it. The reason why is since velocity is changing sign from positive to negative, it changes direction, and then at 12, from negative to positive, when velocity changes sign, it changes direction.
The only thing that gets tricky, and I'll warn this of you in advance, is when you start talking about acceleration.
Right.
That really gets tricky. Figuring out.
Because when acceleration is negative, it just means it's slowing down. It doesn't mean it's changing direction.
No. Well, if we get to an acceleration problem, we can start it. It probably doesn't. Yeah, let's go over the easier parts first. Find the total distance the particle travels in the interval 0 to 20.
So I have a question. So since the particle at time t equals 4, no, it's not an initial condition. Never mind.
Here's the definition of distance traveled. The integral of the velocity function.
Right.
Well, what's that mean? In calculus terms, what do integrals mean?
You're finding the area under the curve.
Correct.
So we can just do it
now,
geometrically find the area.
Exactly. And all areas are going to be positive in this case because it asks for the total distance traveled.
Right.
As opposed to the net distance. And those are very different. In other words, the net distance would be the net area.
Right, and then
This area negative. But for the total distance, we're going to basically take the absolute value of the function from 0 to 20. So if I knew what the function was, that's how I would do it, and I would need the absolute value sign there. Because when you put the absolute value, then it treats all these areas as positive instead of negative.
right.
Okay? So, I mean, you can put it into your calculator if you knew the function. We don't know the function here, so we're going to have to solve it geometrically. But that's not hard to do. I guess we could break everything up into trapezoids.
Right.
Or rectangles.
What is the trapezoid formula again?
That's the whole thing is a trapezoid there. And that is a trapezoid. The area of a trapezoid is the average base. In other words, if I have a trapezoid over here like this, this is base 1, this is base 2, and this is its height. So it's like a rectangle. The way to think of a trapezoid is a rectangle. Okay, the area of a rectangle is base times height. The area of a trapezoid is the average base times
So
height.
it could be B1 plus B2 over 2 times H?
Yes.
Or 1
That's exactly what it is, but that's kind of hard. I mean, you know, if you think of it as the average base, you'll never forget it. Because you know that to get the average base, you do B1 plus B2 over 2.
So would the first shape be a trapezoid?
Yeah, hold on. I haven't drawn these triangles. We don't need that. Let's see. We could do this a couple of ways. There's 2 trapezoids.
Yeah.
1 and number 2. This one is number 3 and this one's number 4. So we basically have 4 trapezoids there.
Right.
And it's easy enough to figure out applying the formula we had. That's fairly simple geometry.
Yeah, I can do that.
Yeah, as long as you know the bases are the parallel lines.
Right.
In other words, this is base 1, this is base 2, that's base 1, that's base 2, base 1, base 2, base 1, base 2. And frequently in calculus, these trapezoids are oriented 90 degrees from the way you're used to looking at them. In other words, usually we're looking at trapezoids like that in calculus.
Okay.
So that this is the height, this is B1, and this is B2. Like when you're using the trapezoidal method.
Okay.
Okay? All right. Let's see. So that is the total distance. Write an expression for the particle's velocity in the interval between 10 and 14.
Wouldn't that just be
This one right here. What is the equation of that?
well,
I think we just need an equation of that straight line.
okay. So, slope is,
There you go.
what is this? Slope is y1 over y1 minus y2 over x1 minus x2. So Um,
16 over 4?
yeah, so 16 over 4.
Okay, so that's the slope. Now,
So
what are you going to use for the formula?
y equals y1.
Well, it's y minus y1 equals the slope times x minus x1. That is point slope format.
Okay.
And this is the one calculus always uses because you always have a slope, because that's the derivative,
Right.
and you usually have 1 point. In other words, we don't use y equals mx plus b because we don't really have the y-intercept. I mean, if we extended this line all the way down there, we could probably figure out the y-intercept and go that route, but that's not the efficient route to go. The efficient route to go is to use the point slope format to come up with that equation. And you can use either point. So pick a point and give me the equation.
I picked 14.8.
Okay, so what's the equation?
Well, I moved over the y1 just to the other side after I did it, and it's y.
You don't need to do that, and it's not actually the format. This is the format. Believe it or not, you don't necessarily solve it for y. In other words,
Okay.
my final answer, and the answer you would see if you had multiple choice answers, would be this. Y minus 8 equals 4 times x minus 14. And that's it. You don't simplify that.
Okay.
Unless your teacher has specifically told you put it into y equal mx plus b format. But this is the final equation in point slope format.
Right. Sometimes multiple choice puts it in slope intercept.
Which means you would have to distribute and move the 8 over and simplify.
Right.
Yeah. Okay.
That's easy.
Let's see. There must be a way to erase everything on here. Eraser. No, they're going to make me erase it like that. Okay. Let's see. Okay, they're going to talk about acceleration also here. Let me reopen this. And I always have to figure this out every time I come up against it. The acceleration questions.
Yeah, well, it is the slope of the velocity, and that's just.
Yeah, the question is when is it accelerating? When is it speeding? The tough questions are when is it speeding up and when is it slowing down?
Right.
You're right. Acceleration is easy. It's just the first derivative of the velocity. So we could figure out this acceleration function fairly easy here.
Right.
I could draw it right below this, and we would just go through and figure out all the slopes and what points were on the acceleration function. But the tricky questions are when they ask about speed. Let me just. Oh man, I only have 2 options here. Huh. Let's read the questions first. Let's see. So, write an expression for the particle's acceleration in that time interval. Well, that's relatively easy. What was our function? Our function was y
minus 8 equals 4 times x minus 14.
Okay, so you're right. In order to figure out acceleration, I need to put this as a function of x and differentiate it.
Right.
So that would be minus 56 plus 8 minus 48. Is that correct?
Right.
So
yep.
And that is v of t.
And a of t would just be 4.
Right. It's accelerating at 4 feet per second. during that whole interval. And it's positive because that's a positive slope. Okay.
Right.
And the last question, yeah, they don't ask you about speed, so they're avoiding the tough part. Write an expression for the particle's distance in the time interval 10 to 14. No, they're a little ambiguous here because they say the particle's distance, not the net change in position.
Right, and it's asking to write an expression.
So what would the expression be? The particle's distance is the integral, the absolute value from there to there. There is an expression in calculus, you've probably come across it, calling, what do they call it? Integration. It's like the distance is the integral as net change is what they do. That's what it's called. Or integration as net change. In other words, if you have a derivative function like we do here, and you want to find out the total distance traveled, you take the integral of that function. But it doesn't just have to be with distance. It could be a sand machine spitting out sand on a beach to fight erosion. Right. It's got a different, in other words, it's got a rate that it spits out the sand. So
right.
If you wanted to know how much total sand was put out, you integrate that formula for the rate that it's putting it out.
Right.
Here, this is just kind of the same question as number B, right?
Right. Well, what I thought we'd do is take the integral of our...
We could do that also.
Oh,
because they want an expression. Okay.
Right.
What's the
so I just...
gonna be?
I took the integral of 4x minus 48 dx, and then I got s of t equals 2x squared minus 48x plus c.
What are my limits of integration?
Well, I'm not sure if they need that just since it's an expression.
Well, they still need that because they're specifying the time interval is 10 to 14.
Okay, I wasn't sure if they wanted to take like an indefinite integral or they just wanted to write the integral.
No, I think they want a definite integral. Only this isn't quite right. There's one thing missing. Notice that all this distance is going to be negative and all that distance is going to be positive. They're almost going to cancel one another out. So the particle is not going to change positions much. However, it's going to go a lot of distance because it's going to go like that and then it's going to go like that. So the absolute value of that function. That way it will treat this lower part. If you use, in other words, if you don't use the absolute value, this part here is negative distance. Whereas this part here is positive distance. You can see they look about the same size. So the particle is not really going to end up at a different spot. It's going to end up at the same spot it started at, right there. But the total distance traveled, the only way you can get that with an expression is if you use the absolute value. I guess you could go from 10 to 12 on that function and take the negative of that. And then you could go from 12 to 14 on that function and take the positive of it. That's the same thing as taking the absolute value. That's what it does with the absolute value. Now, it's difficult to do these manually, which is interesting because they did say no calculators here. So you're not going to be able to plug, oh, you don't need it. You just need an expression. You don't need to solve it. So,
Right.
yeah, so that's it right there. 10 to 14 of the absolute value of that function.
Okay.
Okay? John, I'm sorry I've taken you over. When I do calculus, I lose complete track of time.
I didn't even notice it was past 10 anyway.
Neither. So I apologize for that, but I will let you go.
It's all good. Thank you.
You're welcome. Bye-bye.
Bye.